Sweet. Yay.
Speaking of, give me just a second. Be right back. Okay.
Well, hello there, everybody. How are you? Welcome to Skyter Livestream for this evening, April 25th, 2023. It's been a long day at my end, but hey, we're here to crank out some stars for you tonight. Before we go much further, though, I just want to say hello to Daryl Mason, who's with us. Hi, Daryl. How are you?
Hello, Mark. I'm good. Thanks. You? Hello, everybody.
I'm doing fine, thank you. Fine.
Good.
And you guys will, of course, notice that all the music is entirely new, so it's all different. And so tonight, I figure we're gonna start by. I'll tell you what we're gonna go check out tonight. We're gonna be pointing the telescope north. That means out the back of the observatory, and looking toward the northeast. And we're gonna look at galaxies that are coming up in Canis Venatici, Ursa Major, and Coma Berenices, as well as we drop back down south a little. It'll be really cool. I want to say hello to all the people that have joined us right off the bat. Looks like Cyclone was the first one. Hi, Cyclone. Terry's here. Hi, Terry. And Michael Hedrick's with us. Judy M. And Daisy and Zoe Amethyst. How are you guys doing? It's nice to see you. And we also have Rocket City Astro. What's happening, man? What are you doing tonight with your telescope? Tell me something good. And Rascally Rabbit's with us. And there'll be more joining us here in just a little while. We are streaming on multiple platforms every time now. And I was this close to being able to stream on Rumble tonight as well. I sent out a community message to those of you that are here and listening, and check out the community messages to go do a follow on Rumble as well. I did a radio show with Daryl on Sunday, and we had a couple hundred people view it on KGRADB, which is YouTube. But then on Rumble, we had almost 900 views on Rumble. So I think Rumble is a serious contender. So we're going to be going to Rumble as well as YouTube and Facebook, Trovo, and Twitch. All right.
No idea.
Yeah, I know, right? I didn't either. All right, and I have to thank Bill, New York Skywatcher, for that tip, because he helped us get onto Rumble today as well. So, hi Sam S, how you doing? So we're gonna check stuff out as it's getting darker here. You can see that it's not quite dark in the observatory yet, but it's getting dark enough to look at some things, like maybe we can look at a star cluster. So let's see where we are here. Let's go. Not there. The moon is up right here. Let's check something else out. We're gonna zoom in here, and I don't want to look at the beehive. Let's see. We have this little cluster right here, which is actually kind of cool, right? It's moderately rich. So it's called the GoldenEye cluster, or the Pac-Man cluster, or the King Cobra cluster, also known as Messier 67. So let's try that. All right, so we'll go check that out. All right, there goes the telescope. You can see it heading up, and we will increase our gain. We'll increase our gain, and we're going to increase our exposure here. Because right now, I was doing 15 milliseconds. I'm going to actually do a higher. Yeah, there we go. All right. So this gives us a pretty adequate view of what we got going on right here. We want to actually see this as a dark background eventually, right? So right now you can see there's still some skylight up there that you can see out here in the back. So we're waiting for that to darken. But we can try live stacking this, and if I do, you'll see that every second we're going to get a new image, and of course it's going to be very bright. First thing we do is line up all our curves and color correct, and then we can actually do a little process, and you can see that there's a lot of noise. Why has it got noise? Because the sun is still up as far as the stars are concerned. It's not dark enough yet. Hey there, Asher is with us. Hi, Asher. How are you? And so we'll wait a little bit to make this happen. This morning at 8 a.m., I was actually up at 6:45 a.m. To be up in time to get on a radio show early. It was called WPLR. It's one of the biggest stations in the state of Connecticut here, and they wanted to have me on to discuss the Pentagon UAV and UAP stuff, and that was fun. It was a good time. It's funny how these guys are always like, should we be worried? Do we have to be worried? But it was fun, and we talked about Avi Loeb and how he wrote that article with Sean Kirkpatrick that talked about the potential that the UFO sightings that people see here are just objects that are coming from a mothership further out in our solar system. And it's not that Avi Loeb, the director of Harvard's astrophysics department, it's not like he actually believes that. I know Avi. We've talked a number of times. We've done shows together. But he just is doing something that I do, and that is that he's just saying it's a possibility. You can't discount the possibility that this is happening. You can't discount the possibility that they're here. And that's all it is. That's all this is. It's not him trying to suggest that aliens are here and I've seen them kind of a thing. That's not what he's suggesting at all. He's just raising the possibilities. And as good science folks, we should rise to the challenge and say, okay, we should test that theory. We should test that hypothesis. And that's exactly what we're doing. So his Galileo project takes care of that, is starting that. In fact, that observatory you see right there could possibly end up hosting some Galileo hardware at some point. If not here, potentially further west down this dirt road from where this is located. Because we have another possibility for telescope 3 further west from this observatory. And that takes us toward, believe it or not, darker sky than we have here, which is, interesting. I'm going to, while we're waiting here, I'm going to go in and just grab our all sky cam. And I have to just take our timing and drop it down to something. Yeah, it's at 14. I'm going to drop it down to 4,000. That means 4 seconds. 4,000 milliseconds. There's 1,000 milliseconds in a second. So we save changes and we'll go to preview and do an acquisition and see what we got. This might be too bright still, but we'll see. Yeah, so you can see how incredibly sensitive this camera is. All right, so you can see everywhere. You can also see the bird poop on our dome of our camera, which is not a big deal. You see it's here. This is the highest spot out at the observatory, so birds tend to sit on it and stand on it. So every time Marianne and Tara go out, they get a wet cloth and they wipe it down just in time for the next bird to come sit on it, probably that night, which has actually happened. Yeah, so you can see how high our moon is.
You ought to get, like one of those owl figurines or something and stand next to it. Supposedly scares the birds away.
I was thinking of getting an owl, and I thought, well, we'd always see it in the camera. And it would be in the main telescope view, potentially, but if we stick it, actually, maybe not, because we can put it farther down, and it'll always be in the all sky cam view. But that's okay. We can deal with that. So, let me try something else while we're here. I'm going to drop this down. You can see this cluster. I have not done any photographic focus yet, so that's the next thing I'm going to do. Alright, so we have a bunch of stars here that are out of focus, and I'm going to make them more out of focus, and then I'm going to tell the system to run through its focus run and focus up these stars. Cosmic ray, because there are going to be 3, right? The second one's behind me, and it's going to be scope 3. All right. Sorry you don't like my terminology, but that's the way it is. So scope 1 is actually behind me, Ray. That's the one that we want to. That's the one that we want to set back up out here. That was the very first scope we had. The second scope is what we're looking at now. All right, so that's scope 2, what we're looking at now. Scope 3 is going to be the next one, and we've already got some donations that are leading us down the path to get that one. The Star Arizona folks are well aware of what we're doing. Oh, I made a mistake here. Let's just do this.
Izabela's here.
Izabela, what's going on? Here we go. Okay, these are our out of focus stars. And we're going to bring that focus in just the tiniest bit. And then we will... There we go. And now we're going to get our focusing set up here. And we'll scan inward now. It says too few stars, but it's going to get more. Might have to increase my gain a little bit here. Ray asked, when will Scope 1 be back up? Well, Scope 1 was going to be back up, a year ago. But COVID made the prices of wood go through the roof. So I changed my approach. I'm no longer building a full building for the telescope that you walk into. Now I'm just going to build an automated enclosure. So there will be a cover over the telescope, which will be on a short pier. And it'll just open up like a little clamshell. I've already got the linear actuators. And that's what we're going to use. And it's going to be more economical. It'll be easier to maintain and operate. And it will give us our horizon whenever we want it. So if the building is elevated just a little bit, the clamshells are going to open and drop down on the sides. So it's going to be dropped down like petals of a flower. And it's going to allow us to see all the horizons at all times. The only downside of that is that it's also going to allow us to be subject to wind. So the building protects us a little bit from the wind. And that was the original methodology behind domes and why they built domes, was to protect a telescope from the wind. It had nothing to do with the astronomers inside the building. No, they could suffer, and they were supposed to suffer. But in any case, that's all right. All right, we got our best focus spot. Now we're going to check it out. We're going to rip the stepper motor down one side and back to the other and to the center. There we go. All right, now we have our good focus. And as you can see, there goes a Starlink satellite. You get good at knowing Starlink because the trails are a certain size for 1 second. You know how fast their orbital speed is. And that trail is about like that on the screen. And so that's how that works. In fact, I'll show you what I mean. So if a Starlink satellite comes through in 1 second, leaves a trail about that long, that's what you got. That's a Starlink satellite. All right. Because that's what we notice for the orbital speeds of the satellites. And on the diagonals especially, that's when we know that they're Starlink, because they're actually set up in a diagonal network, like a quilting network. It's pretty cool. All right. This is a beautiful little cluster.
It is.
Indeed. Yeah, and let's go see now. Yeah, all right, this is Messier 67. One of the things I wasn't sure is whether Charles Messier actually discovered them in order or just renumbered them at some point.
I believe they were numbered in the order in which they were added to the catalog.
Okay.
He certainly did not discover all the objects.
Right.
There were a number of other contributors to the catalog.
Mm-hmm.
Pierre Machine being a notable one.
Mm-hmm.
But there were several contributors to the catalog.
Okay. That's true. All right, I'm going to go 5 seconds, and let's see how bright our sky is now. 5 seconds, and a stack. This first one is very telling. Okay, so we'll clear it. I expect we'll see some red. A little bit. And we'll color correct. And zoom this so we can actually get a better idea of what we're looking at. There's the red. Okay. That's beautiful. Yeah, so this is Messier 67. Raise that up. Pull it over. Okay, it's a beautiful little open cluster. And the red you see around here is the sunset light that's still in our beautiful dark blue night sky out there.
Interesting. It's an open cluster, but estimates of its range, of its age, range between 3.2 and 5 billion years. That's pretty old for an open cluster.
Yeah, some open clusters, they stick together. And that's the weird thing about stars. They can sometimes in spite of the fact that they're n-body gravitational problems, they will tend to stick together. And most likely it's because there's nothing else around them to perturb them, and they settle into these weird, very complex orbits about each other. And so we don't notice any major changes to some clusters. And that's why we'll find red giants in some of these clusters, as we have in the past.
And speaking of, I was about to say that
I bet you were.
there are a number of red giants in this cluster.
Yeah, there are. That's exactly right. We have one here. I'm not sure if that one's a cluster member or not, but it could be. But there's one here. There's one here. Okay, there's one here.
Close in inside the cluster.
Yeah, like several in here. One here. Let me color correct again. Let me get out of this and just do that color correction. I was jumping the gun here. There we go. And let's pull this back a little bit. Lighten up our background just a hair. Yeah, and so now you can see we have red giants right in here. You can see all these beautiful red stars. Now, if not close enough, we'll zoom in. Okay, here we go. So you can see these red stars here. Those are red giants that are in this cluster. That tells you that the cluster is evolving in place. I mean, it's moving as a group of stars around the galaxy, and they're orbiting each other. And it's possible that some of these stars have been ejected, or some stars had been ejected from this cluster. Maybe there were more. Maybe it's gained a couple as it's moved through the galaxy. But stars last, especially moderate stars like our sun, they last billions of years. So it's not unheard of that we would see a cluster that might have a group of older stars in it, like this one. So it's a very, very pretty cluster. And again, as I say, it's not quite dark yet, so that's why we have the red noise here. That will disappear shortly. Okay, let's zoom out now to our more full extent. So there you can see,
It has more than 100 stars similar to the sun and numerous red giants.
Yeah.
Total star count has been estimated at over 500.
Mm-hmm. And they're not all focused in here. You're going to have some way out here that are members. So the cluster is in the potential process of distributing its stars to the local universe, but it's not very obvious, right now to any of us. And if you do a proper motion study, and we study the speed that the stars move, well, then we would see that, we'd see how they're moving. Hello, Tricia Ferreira. How are you? Cosmic Ray, I think this particular object has been studied pretty extensively. So I think, to answer your question, which is, has anyone investigated what stars are in the cluster and which are not, I think that information is available. But to learn it, you'd have to go to like the SEDS database or Aladdin online and get the names of these individual stars and see what their distances are. The ones that are all about the same distance from us are going to be in the cluster, of course. So it's pretty interesting. I'm going to clear this and see if we will get a better first stack now. A little bit darker. We can get rid of the red because we're going to color correct. Yeah, we're moving away in time. It'll take us a little bit. Yeah, Cyclone asked about eclipses, solar eclipses, and Daryl, that was good of you to answer. Thank you. I would say this though: if it was a simplified solar system, then we'd have a solar eclipse every time the moon went around the Earth. We'd have a lunar eclipse every time the moon went around the Earth. But it's not. Everything is off just by enough to be either above our plane or below our plane. The moon about 5 degrees above and below at various times of the orbit.
Yep.
So it makes it impossible, especially at the distance the moon is. People think the moon is very close. I used to do this experiment with people, adults and kids, when I would do lectures. I would actually have a model of the Earth and have a scale model of the moon. And I would invite someone up and say, move away from the Earth by the amount you think the moon is, and show me the relative scale of how far the moon is. And every single time, not one person ever got it close. They were always extremely wrong, and in fact, so far off that they didn't even believe it when I showed them the truth. The moon is actually a lot farther than it looks. And that's what's kind of fun about showing people this stuff. That's like saying this, I did another thought thing. The nearest star system to us is the Alpha Centauri star system. It's composed of 3 stars. 2 kind of like the sun that are orbiting each other, and 1 way farther away, a little red dwarf that's orbiting the 2 of the stars. Well, the main 2 stars, if we take one of those stars and we look at its diameter, one of them is a little bigger than the sun. Well, if we take that one and we make its diameter the size of a 25-cent piece, a quarter, okay, and we're holding that quarter in front of us, how far away from you do you have to move that quarter so that the angular size of the quarter is the same size as that larger star at Alpha Centauri would be in the night sky? To get the same angular size, how far would that quarter have to go? And I asked that question, and when people think about it, some of them say, a mile, 2 miles? How about 350 miles? This is why we don't see stellar disks. Is because they're so far away that the disks aren't visible to us because they're so small in angular size.
There's a guy on YouTube that he started out in a football field with a model of the solar system, and then he speculated how far away would the next star be. And he jumped in his car and he drove a couple 100 miles away.
Yeah.
Said, "Here's the next star right here."
Yeah, and
he did this up in Idaho or someplace out here in the west.
Well, if you made the solar system the size of a dinner plate, okay, all up to Pluto's orbit, all right, then Alpha Centauri would be in Washington, D.C. if you're doing it in Connecticut. So that's how far away it is.
If the Earth was a ball 8 inches in diameter, the moon would be 2 inches across, and it would be 20 feet away, 240 inches.
Yeah, and most people don't ever come close to that when you hand them a moon ball and an Earth ball and say, separate them by the relative amount you think the Earth and moon are separated. Most people do it at 2 feet, maybe 3. But 20 feet? Absolutely not. They can't fathom that. No, that's not true. Yes, it is true.
Yep. And as you mentioned, the moon's orbit about the Earth is tilted 5 degrees to Earth's orbit around the sun, the ecliptic plane.
Yeah.
And that's why every new moon or full moon, we do not have a solar or lunar eclipse.
Yep.
It's only when the moon is running along the plane of the ecliptic itself that we get an eclipse, and that's called the line of nodes. When the plane of the moon's orbit around Earth intersects the plane of Earth's orbit around the sun, and that line is pointing directly at the sun. Is the only time we get eclipses,
Mm-hmm.
called the line of nodes.
That's why
It
it's not
tends to
happening all the
happen
time.
about twice a year, but it does precess over time. It kind of walks around its orbit.
Yeah.
And solar eclipses and lunar eclipses tend to happen together, 2 weeks apart.
Cool. All right. Well, I was just waiting for it to get dark, so we spent some time here on Measure 67. I wasn't planning on saving this at all. But I guess I could, huh? Might as well. Keep a record. Measure 67. It's an OC, an open cluster, not an IC. Measure 67, OC. There we go.
At one time, somebody asked, and as you touched on, M67 has been heavily studied.
Yeah.
And it has a lot of sun-like stars in it. At one time, some astronomers thought that M67 may have been where the sun came from.
Right. That's right.
Because it has so many sun-like stars, but it turns out that's pretty unlikely.
Yes, because the chemical composition of the stars in M67, which, by the way, are nearly identical because they're all born in the same place from the same nebular cloud of the same composition, is different from ours. When you look at our spectrum, we have what's called the Fraunhofer spectrum. We have lots of lines for calcium, magnesium, phosphorus, hydrogen, some helium. There's other lines that correspond to different elements in our periodic table, and that represents a composition that our sun was made with, right? The sun didn't make those elements in its core. We know fusion makes elements, but the stars are made with what's there first, and it's hydrogen in the core that begins fusing into helium every time at the very beginning when the star is first born. So when that starts happening, the oxygen, the magnesium, the other elements in the outer envelope of that star, those are just atomic nuclei. The nucleus of a calcium atom, not the electrons, right? Because the envelope of the star that surrounds the core is extremely hot. It's all plasma, and only in the core is this plasma fusing. All right. So in the areas around the core, it's not hot enough to fuse. As an example, to fuse hydrogen into helium, you have to reach something like 13 million Kelvin, all right, in temperature in order to start the process to go from hydrogen to helium. And you got to go to fuse helium into carbon, you have to get up to 100 million Kelvin. Okay, and that does happen. And at the point where we call the helium flash and part of the star's evolution. Our sun is a long way from that. Hey, Lucy Clark. So Asher says, I just donated plasma today. Wrong kind of plasma, but I'm glad you did it. So yeah, that
Asher would be a heavenly body if he had that kind of plasma.
That's right. He should. He'd be hot, man. He'd be atomic nuclei and nothing more, and no one would recognize him. Hey, Uberku, what's going on, brother? So, I saved this like this. So what we're gonna do is we're gonna clear this. It's up there, and if you want to play with it, you can. And we're going to go to our night vision mode here. All right.
Well, it was a nice little cluster.
It was, wasn't it? Okay. All right. And this is the cluster now under our night vision mode. Let me just bring it up. Notice how it's a little more visible now because it's getting darker out there. So let's remove that. Go away. Bzz. There we go. And now let's come back and do something crazy. While we're here, might as well just go check out the moon. Why not? Let's go check it out so we can say we did.
Yeah.
All right. Here we go. You watch the telescope lean over to the left here, toward the west.
About a 5-day-old moon.
Yeah. So we'll see some nice contrast. All right, and we're going to. I'm leaving it like this on purpose, because I want to show you how Earth shine affects the moon. See, right now the sun is to the right, all right, and it's causing you to see it like this, right? As an example, if I take the gain way down, all right, you can start to see the sun is on this side of the ball, all right? It's not shining on this side of the ball. Yet when we climb the gain a bit, we'll see that in fact you can see the other side. You can even make out features. All right. Now, how is that happening? All right. Well, that's happening because the Earth's brightness is reflecting onto this unlit side of the moon, and it is called Earth shine. And Earth shine is really cool. These are stars. Something you never normally see when the moon is out are stars around the moon in a telescope. But that's because, we have the telescope set to look deeper into the sky, so it's overexposing the moon. This is something that the astronauts, when they went to the moon, did not do. See how you see these stars? Well, now if I were to bring our exposure down, okay, to 125 milliseconds, well, you see the stars are almost going away now. And now if we get it down to where we can actually see the moon properly, okay, now we start to see the features on the moon, but you don't see a single star. And that is exactly the same thing that happened when astronauts went to the moon. They set their cameras to photograph the moon without overexposing it. And thus, they captured all the detail of the moon, and the sky looked black. This is the exact same thing. So, for when people tell you that we didn't go to the moon, that's why the sky's black, it was a studio. Well, if it's a studio called the universe, and they just don't know how cameras work. And now you're armed with the information to tell them. The exposure was set to the moon, which reflects 13% or 17 or 18%, I forget, of its light back. And so that means that you have to set your camera to record enough light so that you don't overexpose. But in so doing, nothing in the sky will show. It'll always look like this. It'll always look dark. Hello, James Hyatt. How are you? James Hyatt says, is it possible to link up with a telescope in the southern hemisphere and show what we do not get to see? Yes, that's actually something we're working on. I've been talking to a couple folks down in Oz, Australia, and I would like to get a telescope in Australia so we can do southern hemisphere work. And the nice thing is, when it's daytime up here, because there's such a difference in time, we could be in the middle of our day and it'll be nighttime down there, because I'm in Connecticut. And Cosmic Ray says correctly, we're waiting for someone to offer up a southern scope. That's correct.
You just cut out completely, Mark.
Well, if they say I did in the chat, then let's make sure it wasn't your headset. If I cut out, please let me know in the chat. Okay. So there's our moon, and you got my point about the exposure. So that's what you want to look for, and a good exposure of the moon will leave no bright stars in the sky. And if we were to increase our gain or our exposure or both, then we would actually overexpose what we want to take a picture of. But then you see other things in the background, okay, namely these stars, like that. So we have stars now. That's pretty cool. All right, now that we've done that, I am going to set us back to our 1 second night vision mode. Okay. And it gets very bright in night vision mode. All right. So let's go now all the way around the sky now. Look, Daryl, I have your problem with stellarium.
Mm-hmm.
We're going to go up here. Yeah, see, Canis Venetici is one of the places I want to go. In fact, we could probably start there, farther from the moon a little bit, maybe. There we go. I want to do the sunflower. That's where I wanted to go. That's a beautiful galaxy. All right. Okay, here we go. And away with the moon. All right, and I will bring us down here to a magnification level that shows us things that I want to see. And now we're going to go to this galaxy. This dark circle in here is because we're doing a flat field correction. So when it's dark outside, you won't really see this. These lines are artifacts that aren't really there. They don't show up in the final photos. We're trying to figure that out too, because it's part of the flat field. So I have to do a proper flat field. Oops, I see what I did. 1 second. I ended up bouncing off of here like it was some kind of pinball machine. I'm going to go back. Okay. And I will set my speed of the telescope. There it comes. There it is right there in the Sunflower Galaxy. That's really pretty. Okay, now let's bring it up and get it into our field of view. It's still not quite dark yet, because if it was, you wouldn't see this gradient here. You've seen a sunflower with us before, Daryl, right?
Oh yeah. Well, I suggested it a week or two ago.
Yeah, that's true, didn't you? Okay, so now we'll zoom in here.
M63.
Yeah.
If you ever saw Timothy Ferris's book Galaxies.
Great book.
Yeah, M63, I believe, was actually the galaxy on the cover photo.
Nice. It deserves to be there. Okay, we're waiting for a guide star. That's what searching means up there. There we go. Zeroed out in right ascension declination, and then we start doing our guiding, and we just wait a couple seconds to get it stable. And there we go. We're ready. So now I can do our 20-second shot. So we're going to drop this down, go to photo mode, and stack it up. That's our previous object, which we'll just clear. That was a really pretty cluster. We'll pull that away. Very nice. And this is the Sunflower Galaxy, it's called. And you'll see why in just a second. Let's color correct and do a proper balancing. And now let this make its way in. As we stack more on top of each other, you'll see this beautiful pattern emerge in here. What we do is we take an image, and we take a second image, align it with the first, and put it on top. And we keep doing that. All right. And that gives us a beautiful, a very, really really beautiful noise-free image.
Yeah, Izabela, the book Galaxies by Timothy Ferris. It's a classic. It was done in the days of film, though, I do believe, and it's probably badly outdated nowadays.
It is.
Unless he did a new edition.
I haven't seen a new edition.
Yeah, I have it on the bookshelf.
Mm-hmm. There we go. I'm going to add an enhancement. I'm going to add an unsharp mask. We're going to try to enhance these spiral arms. So I'm going to zoom in a little more. Okay. And now, watch the spiral arms when I hit the enhancement. Here we go. Ready? Enhance. There. So now you can actually see these dark lanes in here quite clearly. That's really nice. If I shut it off, you'll see that they get a little fuzzier. The unsharp mask is a great way to do this. It's called a convolution matrix. I actually designed some. We wrote a program that the Hubble Space Telescope team were actually using for a period of time. My friend John and I. And it was just two of us. And we wrote this little image processing program when Hubble first went up. That's how long ago it was. And the Hubble team used our little tiny program. It was called Process Pro. And they used it to actually do full-blown analysis of the Hubble shots. You know, it was a Space Telescope Institute actually that used it. So we were very proud of that, but obviously we chose not to keep it up because we actually had full-time jobs at that time. You know, so we couldn't keep it up, and so they moved on to other products, and we were happy to see that because it was tough keeping up with all the expectations. Yeah. James Hyatt says a very nice looking galaxy. Yes, it is. Yes, it is. And once again, this guy is the Sunflower Galaxy right there. Let me move that over a little bit for you. There you go. Really pretty galaxy. Now that we've stacked 11 shots, you can actually zoom in a little more. I purposely only did a 20-second shot of this because I didn't want to lose the detail in here. Okay. So this allows us to preserve that detail. It looks really good. And we can just show a little more in there. Our gain is actually pretty low. It's actually at 147. So normally I shoot at 300 or 250. And the gain, all right, and what am I talking about when I say gain? Well, I'll show you, okay, because it really comes down to this. This right here is the exposure. The exposure is how long I'm allowing the sensor to receive light. And then the gain here is how sensitive I make the sensor. So the higher the number, the more sensitive it is to light, the lower amount of light can really trigger it. So you play with gain and exposure and you get the best combination of the two. That's simplified. There's other things we do. One's called binning, but we don't do binning. I prefer to just get the full sensor. So right now our setting here is 147 for the gain. So we'll zero this out and go to 200 and see what we get. We had to wait till it got really darker to actually do this right. Hey, Bullwinkle. All right. So now you know exposure and gain, the two main parameters. All right. Now this is Sunflower Galaxy. All right.
You gonna try cranking up the gain?
Yes, I'm saving it first before I do that.
Ray
Okay.
says your stars look kind of blobby. I don't know if you need to refocus or not, or if maybe you got wind.
Yeah,
They look kind of oblong.
it's a little windy tonight out there. So we do have wind. I mean, I just focused a short time ago, but I can try it again anyway. So we'll do that. So now you guys have to wait, and it's all because of Ray. Just kidding, of course, Ray. Now let's see how this looks. I know we had some wind out there for sure. All right, I'm gonna pull this out. Yeah, see? And then we'll go in. And I'm in a magnified view, but it sees the whole frame. It's looking at the whole frame. Yeah, Asher, the wind does blow things around a little bit. It actually makes it hard for the autofocus system to work too. And that's problematic as well.
Not even astronomical twilight in Arizona yet.
Yeah. We're pushing
12 minutes.
Yeah, we're pushing it. Is blobby an astronomical term? Oh, no. That's a Ray term. Ray says, I'll just sit here and eat a crayon. No, Ray. You got to put it on the radiator and melt it first. Okay. So we have our best focus. We got a few more points. It'll refine this as we get more points on our curve. That looks good. That's a pretty good curve. So we'll use that. Now we'll get the focus running. All right. All right. Now what we can do is try again. This time though, we're going to try a 25-second shot. 25 seconds. We are guiding nicely here, as we see. So off we go. Right there. I'll throw on T-Comp and go into our live stack. See, folks, this is easy. You just got to do like 8 things at once. It's kind of crazy.
You want to turn up the gain?
Yeah, you're right. I left it at 147. Okay. I thought something was missing. Alright. Alright, we'll go here. 247. That's good. Actually, I'll round it. I'll make it just 250. Alright, there's our gain at 250. And so I'll clear this now. And then for this next shot, I'm gonna clear it because the gain is mixed. It's a mixed gain on that shot. You don't want to change the gain mid-shot because all of a sudden the sensor gets more sensitive and you get artifacts sometimes. Clyde Tombaugh never told me he used that term.
Which term?
Blobby.
Oh.
Okay, let's... This looks pretty good. The color match is good. So let's tone down the center. Okay. Alright, now we got some noise, but we only have one stack. The second one coming in will fix that a lot. Watch. Okay, like that. Alright, now you can see more detail in here. and even more as we're moving forward. And we're going to drop down this background noise. Look at those beautiful spiral arms. Yeah, that's the sunflower galaxy. That's really pretty. Pink. By the way, hi Michael Hedrick. I didn't say hi to you, and there you were. You've been here the whole time. I apologize. Nice to see you. I did not see any auroras, Ray. Ray's asking about auroras. How many folks saw them? Did you see any, Daryl? Daryl, did you see any?
Sorry, you're cutting out again. No, I went out and looked several times. It was too cloudy here. They were spotted several places here in Colorado, though. One down in the San Juan Mountains, down in southwest Colorado, and then one by Rocky Mountain National Park in the north, and another one somewhere else up in northern Colorado. I saw at Space Weather that somebody way down in southwest Texas, Terlingua, Texas, took a picture of them.
Wow.
They may have been too faint to see visually.
Was it a dome?
I'm sorry?
Was it a dome, or was it like ribbons?
It was low on the northern horizon.
Okay. I remember in the 80s, where I'm living right now, in the town of Terryville, Connecticut, we were literally the radiant. It was right over our heads, so you saw them streaming in all directions from directly over your head. Yeah. That's where they were entering the atmosphere at that point. Yeah. Trisha Ferreira says, looks almost like a fried or poached egg. Yeah, it kind of does, doesn't it? Go ahead, Daryl.
About 2 solar cycles back, about 22 years ago, we had quite a run of visible auroras here in Colorado. And I remember there were a few times, didn't even have to drive out of town to see them. They were bright and obvious and very colorful, even from here in town.
Yeah, ours were spectacular. Ours were green ribbons, and then you had some red oxygen auroras that occurred later on, and by 3 in the morning, the entire horizon in all directions was a homogeneous pink glow. And it reminded me of that Star Trek episode, For the World is Hollow and I Have Touched the Sky, where the people were living inside of an asteroid, and they would be on the surface briefly, and their sky was just pink with no stars, no sun, no nothing, and that's what they thought was their life. That's what they thought their planet was. But it wasn't. Yay. Crown Point, Indiana. Daisy and the Cowboy. Hi, guys. How you doing? It was great to see you at Marianne's at one time. Cosmic Ray mentions 1988 at Stellafane. Clyde Tombaugh was there. I actually talked to Clyde at that very conference in 1988. And I got to spend some good time with him. Yeah. I think Clyde gave a talk under the tent at that place at that time, Ray. Yeah, Ray says, yeah, I've never used illicit drugs. I don't smoke, I don't drink. I am really boring, but I tell you what, the universe is exciting enough. I don't need it. Look at it. See how the arms are so beautiful now? We can now zoom in on this some more. Yeah. Look at that beautiful galaxy.
Dark bar there across the front.
Right there.
Yeah. Actually, it looks like there's another one to the lower left of that.
Right here, you mean?
Of
Another
right there,
another
right
bar,
there,
right?
to the right from there. Yeah.
Right here.
Yes.
Yeah. Well, let's see if there is. Let's see if we can push the entire image. See what's really hiding there. Yeah, there is. See? There
Yep.
is. There's one there.
When I worked at the mine, 40
Leadville.
plus years ago, yeah, up in Leadville, one of the guys on the crew was a biker, and something always seemed kind of off about the guy. Turned out he was taking a hit of LSD daily before he went underground.
Wow. He must have had problems with being underground.
I couldn't imagine.
I mean, you know, when you look at the height of some of those tunnels, you know, you walk in. I've had the fortune or misfortune to walk into a mine like that, where it was only just over your head in height, and you're expected to walk in hundreds of yards, sometimes a mile, you know, in that kind of thing. It's like any collapse whatsoever and you're done for. And you can't help but think that. And I don't envy those guys. And Marianne is here. Hello, Marianne.
Hi, Marianne.
Yeah.
It was a hard rock mine. Most places were safe as houses. There were some areas where the roof tended to come in, though, and or the back they called it. And it was spooky one day. I remember we were at a intersection of two railroad lines, and it was a location that was considered quite safe.
Okay.
They had the back was unsupported there, and a big, huge section of the back, like a big, huge rock slab, like 20, 30 feet long and 10 feet wide, just fell out of the blue one day.
Wow.
And it was supposedly a safe area.
Anybody hurt?
No, it happened right before a train came through.
Wow.
Blocked the train.
I bet it did.
I could tell stories that curl the hair on it, but
Yeah.
that's for another time.
This is beautiful. We have 19 stacked right now, 20 stacked now. And we see the Sunflower Galaxy. This is really, really pretty. And I will leave Sunflower Galaxy there. We've got 20, so I can say save right now. And save exactly as seen as well, which we'll do. So now our image is saved. Now when I'm saving these, where they go? For those that don't know or don't remember, they go out to our server, which you can find at skytourlive.org or skytourlive.com, incidentally. It doesn't have to be the .org site. Depending on where you live in the country, sometimes the .org takes a little longer to come up. But it all goes and resolves to skytourlive.com. So if you go to it, you scroll down to just the next section. It's sort of a gray color. And that's the Take Me to Really Cool Pictures site, and it takes you on out to our server, where these pictures are up there waiting for you. If you want the highly processed servers, go to skytourlive.com or skytourlive.org, and on the upper right, you can select our Patreon and join our Patreon for $10 or more a month, and you'll actually get a number of these pictures highly processed each month for you to do what you wish with. And we also have products we're coming out with. We're up to like 54 different products: mouse pads, cups, glasses, mugs, bedspreads, all with our imagery on it, and it's knockout stuff. It's really, really cool, and we'll be getting that going really soon. I know I've been saying that for probably a month now, but we finally are kicking into high gear on it. We had to wait for some of the folks working on our background imagery, like the logos and stuff like that, to formalize all that stuff. I just want to move 100 miles an hour because I think this stuff is so cool. And that's also something else that if you join our Patreon, we're going to start offering at the different tiers. We're going to offer different gifts, okay, just like NPR does. Okay. Hey, Hunter. We're going to offer some gifts at the different tier levels. So it'll be things as small as a refrigerator magnet. And for the heavy hitters who want to spend even more on the higher tiers, they'll get some nice tumblers or lamps or sneakers that have our objects on them. I have a pair of sneakers with the Soul Nebula on them, and it's just so cool. You know, they're the Converse style, but you can also get low sneakers, not high tops. So it's really neat. Decks of cards with objects in the back. It just goes on and on. I mean, I was amazed. Journals, hardcover journals. Stationary stuff, in other words. And carry bags, luggage. Imagine luggage with a gigantic nebula on it. You can't miss your luggage in the airplane. I did Alien Con, and I went out there with a gym bag that had a nebula on it, and it said skytourlive.org on it. And everybody was like, "Where'd you get that bag?" Well, it's one of our products. Wow, where do we get it? Yeah, it's kind of cool, you know. Anyway, want to welcome Near Earth Objects. How you doing, man? Thanks for joining us tonight. Make sure you subscribe. Also go to skytourlive.com or skytourlive.org and check us out. We do this on clear nights. And we're stacking. We're up to 30 now, and I think we're going to pause it right here. And look at the detail. That's going to come out really nicely when we actually process this. And move some of the noise a little bit here.
Mark, will you excuse me a moment, please?
Sure thing.
Right back.
Yeah. All right, so we save it. And then we're going to save it exactly as seen. There we go. And Michael Hedrick asks, a question for Mark. From end of last feed, just before he finished, do we have data on what % of the galaxies are on their side from our perspective versus head-on? Actually, that's a very good question. I do not know that number, Michael. Face-on galaxies look like this to us with the spiral looking right at us. Most of them are like this. They're kind of at a 3/4 angle. They're not edge-on. They're not face-on. They're somewhere in between. Most galaxies are at the somewhere in between. I can tell you that for sure. But we do have some galaxies that we do have some face-on beauties. And maybe we'll see some here in a bit. You notice our little spider web in the building here is moving quite rapidly. That shows us that there's some wind out there. So there's some wind building up in there. And as the desert heats up during the day and gets to about 90 degrees, at night we get that cooling and the air currents pick up for a period of time. And we're kind of in that right now. So we're going to clear this because we've already saved it. And move on to the next one we want to look at. There's some beautiful galaxies out here. Beautiful galaxies in our neighborhood. Sure. Alright. And let's do this. Let's drop this down to 33% so we can see the entire thing. Let's get rid of that. Blah, go away. And just in time for a Starlink satellite. It almost hit our words. Alright. And Terry asks if we can see NGC 2903 tonight. I'll see. Cyclone says, question for your high tier patrons. Can you make your face on a blanket? My face or your face? Let me know. All right, so let's go back now. I'm only doing 7 things at once. Let me bring back our computer right there. Okay, good. And now let's do this. Let's go look at the Croc's Eye Galaxy, which is next. And then we're gonna wind our way down to the Whirlpool. Okay, there we are. So these galaxies are all in close proximity to each other, and I really kind of like it. All right, so we'll see the next galaxy show up here in the view as a little fuzzy spot. There it is. And it's called the Croc's Eye. Why? You'll see. But I'll tell you, to be honest, even I don't know for sure. Okay. Now let's move the telescope a little bit north and a little bit west. Okay, and then a little bit west. And that should do it. Alright, and then we'll search and wait for our guide star to show up there. And the way that works is you can't see it here because it's on the other side of the telescope. There's a whole nother telescope on this telescope. And it's a guide telescope. And it's looking for guide stars, and it's guiding what we do. Right? It's guiding on these stars. So it keeps the star in crosshairs. Like if you can imagine these crosshairs, okay, on the screen. It's guiding so that the guide star stays right in the middle of where they all intersect without deviation. And to do that is quite a feat. It's called an auto guider. And so it's auto guiding in the background for us. I tell you, it's like I tried to leave no stone uncovered, no stone unturned, in trying to make sure this is a good system for everybody. Okay, now we're going to do this as 30 seconds because there's some stuff in the outer rim that is really interesting to look at. So we'll come out of night vision mode here. And if you're wondering how long it'll be before our image comes in, well, you just have to look over there at this little area right here. This is our yellow progress bar in the lower right corner. And when it finishes here, you can see it. Make sure you're on 1080, by the way, 1080p resolution, and you'll be able to read all these menus and things. Okay, here's the first image of the Croc's Eye. All right. And hey, welcome back, Daryl.
Thank you.
Yeah, the sky is pretty dark now. Now, see, we can get to the Black Eye Galaxy from here. We can do the Whirlpool Galaxy from here. Black Eye is over toward Coma.
You say this is the Croc's Eye?
It is. And let me try pulling down a little bit of the brightness in there. So we can see some detail inside there. Or well, we'll let it develop, see what we get. Let's do this. That's a little too bright. Pull this a little there. So the Croc's Galaxy that you see here.
M94.
Yeah, M94. And what's interesting about it is that it's actually it's a regular galaxy with fairly tight spiral arms that are just on the verge of going from looser to a little bit tighter, and thus it's called an SAAB. You can have an SA letter S, letter A, capital S, capital A, little a, or a little b, or a little c, and the A is for tighter arms, the B is for moderately wound up arms, and C is for very loose arms. This is a capital S, capital A, AB. It's a galaxy that's on its way from being kind of moderately wound up to maybe winding a little tighter due to the slight differential rotation we see. This red square, by the way, is our field of view. And if you look at where the writing is, you have to turn your head to the left and align it to make this the top and this the bottom. So you could see, for instance, where the stars in the field are, and they correspond to what we're looking at here in this view.
I remember this galaxy now.
Yeah, we did it the other night.
Yeah. There's the bright inner, and then the inner halo around it, and then the dark ring around that, and then another fainter light halo outside all that.
Right, because look, it's got this dark ring around it.
Yeah.
That's probably why it's the Croc's eye. Hello, Cindy Murphy. Nice to see you. James Hyatt says it's his first time seeing this one. Yeah, let me see if I can make it more memorable by making that nucleus a little more visible here. There we go. That's nicer. See that? Look at that. How we can zoom in. You can see the spiral arms. You can see the dark dust in here. And just so you know, that's right here. You can see that dark dust right there coming down. See that? Right? And then we have more weird areas here. There's like a void right there that's kind of interesting to look at. Not sure what's happening there. But we also have this very bright center, right? And then we have this whole area of the galaxy we're seeing here. And then on the outside, we have what looks like a dark ring. See it? See this dark ring that kind of goes all the way around here? Isn't that weird? So that's something to explain. Yes, I was in space. All right, so we've got 11 on this one. We'll do 12 and then move to the next. By the way, I am meeting for the second run of the 4 filming days for A&E's The Proof is Out There. And today is the 25th, so in 3 days I meet with them to discuss my new packet of 10 to 12 stories. And then I will be filming that like a few days after that. And then June 2 through 4, I'll be at Indian Wells in California at Contact in the Desert. And I will be doing a SkyTour live stream, live presentation, observatory show. And I will also be doing a regular lecture. I'll be doing a lecture on UFO propulsion and how physics might actually lead us to clues about how that could actually work. So it's pretty neat. All right, I think this already did it. I'm just going to make sure. There we go. Okay. So that's pretty. That's really, really nice. So we're going to leave that one as is. All right. And we'll come back and go to our night vision mode again. And there we go. And back out. Terry Hay asking if that's also the cat's eye. I don't believe so, Terry. I think that this is the Croc's eye, or Measure 94. Let me say. Yeah, Measure 94, Croc's eye Galaxy. All right. Yeah, we did sunflower. I mean, we're in the neighborhood, so let's just drop down here. Let's go to the Whirlpool. Everybody loves the Whirlpool. Alright, this is a face-on Galaxy. It's facing us like this. It's not on an angle to us. So it's going to have some really interesting, real interesting look to it. There it is. All right, let's go north and west. All right, there we go. Cyclone says, if aliens were to exist, would they be scary and evil or good and peaceful? Well, probably any and all of the above. We don't know. No way to know. If we were the aliens, it's like you have friends that are wonderful and kind, and then you have friends that are rotten and terrible. Maybe not to you, which is why you still call them friends. Okay. All right, let's set up we'll go 35 seconds on this. Okay.
That reminds me of the, I think it's the opening of the movie Valerian in the, what do they call it? It was a Luc Besson movie, the guy who made Fifth Element. Valerian and the City of 1,000 something or other.
Okay.
They showed at the opening when humanity out in the cosmos started meeting other alien species, and A, how different they all looked, and B, how scary some of them looked, and you know, that you might misinterpret their fairness or lack of, or you know, their beauty or lack of, or their personality, I guess, for want of a better word.
Yeah. I think it's kind of funny because if you think about it, there's no reason. I mean, oh, that's pretty. There's no reason that aliens have to look remotely like us. You know, they could be extremely elaborate beings. Can you imagine if they actually came out and they had like just like they were a walking arm with a hand on their head, and you grab them by the head and shake them viciously, like you're giving them a handshake, okay? And it's like, you know, Peter didn't realize it, but he started an intergalactic war by attempting to shake hands.
I was about to say.
Okay, let's zoom in now. Whirlpool is always beautiful.
I tend to agree with Stephen Hawking. I mean, we should be keeping a low profile.
I think that'd be great, except that we've already been announcing our presence very loudly for 2.5 billion years. Because if you're a carbon-based being in our galaxy, well, you know the story. You need oxygen to survive and to help you make energy. So therefore, you're going to look for planets that have oxygen in their atmosphere. And Earth stands out like a blazing blue beacon of blue in the cosmos. So it's screaming, life's here, life's here. So I don't know. We don't have a choice. We can't hide. All right, let's color correct one time. Oh, look at that. That's beautiful. That's only 4 stacked. That's because the Whirlpool is pretty bright. This galaxy is really interesting because if this is the plane of that galaxy, its arm is going like this. I've said this before. Its arm is tilted down and it's tilted down toward this one right here. This is a galaxy that collided with this galaxy, right? And as it collided, it's dragging this arm down with it as it moves through. And it's probably responsible for this portion of the arm because it probably hit right there, dragging through. And again, we're seeing a snapshot in time, aren't we? So we're just seeing a snapshot in time. Yeah, you can see some really tight, beautiful, knotted dark nebula in there. Oh yes, I'm in a little more now. That's pretty. It's amazing how orange this looks compared to how blue this looks. You know, in the spiral arms of this galaxy, and you pointed this out before, Daryl, there's a point right here. It seems like a point. It seems like this galaxy is pulling the contents of this arm toward it. And yes. Again, it's doing this, is dipping down. Because if I remember the study, this galaxy is further into the page, so further away from us than this galaxy. So it's tugging and pulling this arm downward. Donald Kunzer says, if someone is listening, won't they take note that we've gone from radio to data? Absolutely. There's no doubt about it. They'll hear static where they heard some type of voice and song in the past. Yes. So that's true. And what type of data that? I mean, who knows? They could be listening to the 5G network static. You know. And Cyclone says, in your recent live SkyTour radio, you had talked about some of the galaxies that JWST had caught. Some of the furthest galaxies could be observed. Okay. Let me read this again. Had caught some of the furthest galaxies. Could the observed universe be extended? If I recognize your question, you're saying since the James Webb has been seeing galaxies that are so far back toward the Big Bang, could the universe size be extended? No, I don't think so. I think we know that the universe is about 92 billion light years in diameter. And you might say, but wait, it's 13.8 billion years old. We can only see 13.8 billion years, so therefore it's 13.8 billion light years in size. No, it's not. It's because the universe, for the time it took for that light, 13.8 billion light years away, to get here, took 13.8 billion years. All right? And then the universe grew in size after that. So it's even further now that it grew over 13.8 billion years. And you see how far it went in 13.8 billion years, so it's still going. So it's sort of like it seems endless, but in the end, when you calculate and take into account the acceleration of the expansion, then you see that the universe has been expanding out to about 92 billion light years in diameter. Isn't that crazy? And of course, there's the age-old question. If it's expanding, what's at the edge? What's just past the edge? I don't know. Nobody does. We have no idea. Okay, 12 shots here. This is good for this. This is a bright one. Change the name. This is Measure 51, the Whirlpool. There we are. Alright, there we go. That will save it. Alright. Save exactly as seen. Nice. I always wonder who might be looking back at us from places like this. Okay. Yeah, we definitely got wind. Look at that. Okay. Now we get back down. Okay, let's bring this up. Okay, now let's go check out something else. We'll do the sunflower. What I'd like to do is head south into Coma Berenices. We can try this. We can try the Globular Cluster Measure 3. What do you think of that? What do you think of that? Yeah, okay. Hey, Kathy. All right, here we go. Measure 3. We should see a fuzzy spot show up in the view. There it is. That's really nice. Okay, so let's go north. Yeah, we don't have to go east or west. Globular clusters are strange oddities in our galaxy. They're called halo objects because they form a halo around the entire galaxy and orbit outside the galaxy. But they do plunge into the disk of the galaxies in certain locations. That does happen. And so there's thoughts that maybe when they do that, they leave behind stars or pick up stars. And that's very possible. This one here, we'll zoom in a little bit. This is only a 1 second shot, but it's fully resolved. You can see it all the way to the center. Look at the wind. See how the wind is making these stars elongated? Oh yeah, look at that. Yeah. Won't be worth taking a picture. Because we have wind on this. Alright. James Dugan's with us. Hey James, do you know anybody down in Australia that might want to provide us some land to put a Australian observatory on? Since we'll have Starlink, we'll have to check to make sure that it's in that region, wherever it might be. Yeah, we're getting a lot of wind, guys. It's that time of night, I guess. That time of night. Alright, let's see if we can move a little further. That's what I want to see. Let's see if we can see the black eye galaxy, shall we? Might be a little bit low from our vantage point. Watch the telescope and see if it's gonna yeah, you watch what happens. It's gonna go probably a little bit low, but maybe not. Let's find out. There it is. Alright, good. We did not impinge on the wall of the observatory. Oh, James, I know what you're saying, but just wondering if there's anybody else that would have some land that they would like to allow us to utilize. I'd love to know what's going on down in the southern hemisphere, and you're so lucky. Well, then again, you think that we're lucky because we get other things, I guess. So let me just drop this down. There it is. Okay, we'll try to take a picture of this object. It might not be the easiest because the wind is misbehaving right now, but you know what? We'll give it a shot. If you have wind like this on a telescope, you typically shut down right away. I go to about 12 to 15 knots at the most, and we have a little bit less than that right now. But it's supposed to go to 22. Okay, so we're searching now, and let's watch what happens. Let's zoom in on this. Alright, we're calibrated to zeros, and now we're guiding. And let's go and make this a 25-second shot. Look at that wind. Oh boy. Well, you know what? We just have to see, right? Just have to see if we can get it. Alright. We'll just see what we can do. It may not be very good. And look at Whirlpool. It came out great. Look at that. Nice color and everything in there. That's nice, Daryl. Okay. And there is the black eye galaxy. Right there. And it's called the black eye galaxy because it has a black eye. At least that's what it looks like.
I'd rather fight than switch Galaxy.
I've never smoked in my life, but my parents were heavy smokers, and they smoked the type of cigarettes for which that phrase was developed. I think it was Terrytons or something crazy.
Yes. We've had this conversation.
Okay.
Terryton cigarettes. I'd rather fight than switch.
And the guy in the picture had a cigarette in his hand and a black eye.
Uh-huh.
Yeah, I always hated that ad because I hated cigarette smoke in my face and everything. I learned early to hate it, and I never tried it and didn't even try it. I guess because I was passively doing it all my life because my parents were. That's alright. It's not for me. Okay, let's you can see that the wind is affecting our image. See that the stars are already dragged out. Let's clear this in time for this next one. See if we can get a clear image. Still dragged out a little bit. I see James. James is telling us about another person up the coast from him. Well, Cosmic Ray asks, how are you going to get land down there when only 6 people down there know about STLS? Wait, Ray, you're a bundle of compliments. Well, the truth is that I may or may not have to go through individuals. You know, I probably could go through foundations and organizations and go that way. So we'll see. We'll see. Let's zoom in. This is the Black Eye Galaxy. We're going to let this develop for a little bit. I can see the stars, though, aren't going to be good. But we'll let it try it. We'll let it work it out. See what we get. Hey, welcome from Olympia, Washington. Lathrop Media. How you doing? Nice to see ya. Why not subscribe and join the thousands of folks that enjoy our streams? What's funny is we're streaming on Twitch and Trovo, Facebook, and YouTube. And I worked out getting my Rumble account today. It was this close to streaming to Rumble. We did our radio show on Sunday nights. We do Sky Tour Radio. Daryl, of course, is a co-host with me on that, along with Tara Diulis, who is our Sky Tour live streams secretary in our organization. And Daryl and Tara and we talked about the James Webb discoveries, and I noticed the next day that the number of views in Rumble of our radio show was up to 880. So that was pretty good for overnight. So I have to figure out how views work in Rumble and what they call a view. Is it a 5 second? Is it 30 seconds? I don't know. But not bad. You know, not bad at all. And coupled with the views we had in YouTube and so forth, it wasn't bad. So we're getting some good airplay. The only thing we need, though, is to get people to join our Patreon and support us. You know? costs us a lot of money each month to bring this to everybody. You know, can you imagine, how much it costs us to buy that telescope, just a telescope? Holy cow. And then build a building and make it robust enough to work from 2,500 miles away. I'm in Connecticut. That is 2,500 miles away in the desert of Arizona, that telescope right over my head. So I'm close in name only. But I worked out all the bugs to make sure that we could bring it to you relatively flawlessly. It's rare that we have anything serious happen, but when it does happen, we fix it. We've got people on standby out there. They can run out and help. But it's really good. It's a wonderful experience. But for those of you that haven't subscribed yet, please subscribe. And also go to Rumble and follow us or subscribe over there too. I mean, it's just a wonderful, and it helps us greatly. Now we're trying to, get more and more attention to what we're doing. No one does this. No one does this at all. There's no one that does this kind of presentation, shows you objects. I show you like the Black Eye Galaxy. You see that little black in the central area right there. No one does this stuff. No one shows you this stuff. And so this galaxy, the Black Eye Galaxy, that's a dark nebula. That's a dark cloud of dust that is shrouding this nucleus. And for whatever reason, it's mostly on one side. And so that weird distribution is due to how this galaxy developed. And there's lots of stories and theories and ideas about how that happened. But it's very cool. Ray says perhaps Dylan O'Donnell will join in. Yeah, he's down there, right?
Yeah.
Yeah.
That's why I laughed.
Oh, really?
I am not a fan of Dylan O'Donnell.
Well, that's not for any of us to say. Let him.
Well, he's full of himself.
Well, this stream makes no judgments of anybody.
Oh well. Just my personal feelings.
Yeah. Well, this actually, for the wind issue, it's actually not that bad. Not that bad. We're going to go to 17 here and then we'll stop. So we'll pause it here and change the name. This is the second time this season that the Black Eye Galaxy has been visible to us and that we've taken pictures. I'm wondering, I'm noticing that each image has a fair amount of noise. And our temperature is minus 14 Celsius. The temperature in the building right now is 21 Celsius. So actually almost 22. No, 21. So it's pretty warm in the building right now at the telescope. Okay. All right, let's all right.
Supposedly have a 12-knot wind out there right now.
Yeah, and that's that's something that we do. I have to worry about. And you can see the stars just keep getting lengthened, and I do not like that. Well, I think we can err on the side of caution and probably shut down for tonight. We cannot stress the telescope. The telescope's finely balanced, and if you have wind hitting this big shield here, that's a dust shield, dew shield. It's like a sail, and it starts pushing it around, and it strains the motors. And we can't have that. It's well balanced, but it doesn't mean that it's perfect. So when you strain the motors like that, you're putting an inordinate stress on one axis, and that shortens the life of the motors and can cause us problems. So I hope nobody is offended, but I am going to have to shut down for tonight. And I hope to see you on the next clear night. And, well, you hear that music. That's our music. That's our closing music. But, hey, guys, thank you for coming out and enjoying this little while we had. I don't even know how long this went because I can't... oh, I see it now. It's almost 2 hours. All right. Good. So I feel good about that. We did about 2 hours. All right, well, folks, next clear night, we'll be back. And I look forward to talking to you and seeing you. Make sure you subscribe to us on Rumble, YouTube, and go to skytourlive.com or skytourlive.org to check out everything we have to offer, including our Patreon. We would love to have you as supporters of us for our Patreon, because we definitely need it. Anyway, you have a good night, guys, and we will talk to you next time. And remember, keep looking up. Good night, everybody.
Good night, everybody.